Okay, so the first thing we're doing is getting the amount of leading zeros that we have. So we'll do int front equals third, count leading 0 from, and then I'll check if this is already a perfect power of 2 or not. So we'll do bool is power, we'll do third pop count from equals 1. And if it is, if this power, we'll increment the front by 1. And then we'll actually return this. I'll just do it quickly, but actually no, let me tell you right now. So what happens in the binary representation is, if something has a perfect power of 2, exactly has 1 1. So for example this is I think 16 if I'm not wrong. Yeah, this is 16. Then this would be 64. Any perfect power of 2 would be would only have 1 1 in the entire binary representation of it. That's why we're checking if the pop count is exactly 1. But then why are we incrementing it? Because we first took the amount of leading zeros that we have. We were going to kind of push the first one to this 0. But by incrementing it, if it was already a perfect power, we would have just pushed it to this 1. So yeah, okay, lots of nonsense. We'll just return 1u. We'll do size width minus front. Because we're doing it from the left side, we'll have to subtract from the size width because we are getting it from the right side. That's good enough to understand anyways. So yeah, and it's an edge case if from greater than size max by 2, return size max. But if it was something else, like not just size, if it was a template type T or a macro, you'd have to manually do a bit flip of 0 on that type, and then that would work right away for the unsigned types. If it was signed, you would have to put 0 on the first bit if it's fallen 2's complement or anything like that. Okay, so there's that. I'll just go and check if it works or not. Int main, do actually a folder for I, int I equals 0. Then yeah, that's much better. Let's take a look. Yeah, as you can see, it works right out of the box, doesn't it? And for size max, it will of course return size max too. So yeah, I hope you enjoyed that. Yeah, anyway, see ya.